Last time, 2 agents lost. The autocomplete assistant clamped the number and hid the bug. Cursor added an in-process mutex that goes green on one machine and oversells across 3. Only Claude Code fixed it. And the reason wasn't a smarter model, it was one habit. It read the schema, the compose file, and the test before it wrote a single line. So here's the obvious question and the whole experiment for today. What if the losers weren't dumber, just blind? What if I hand them the exact same files, Claude Code read, on the exact same race condition, and see whether context alone closes the gap? Same bug in reserveStock, same rule, fix it, don't touch the test. This time, no one has to go find the truth. I'm putting it on the table. Here's precisely what changed. Nothing about the models, nothing about the prompt. I attached 3 files to each agent before asking for the fix. The migration 001 products.equal so they can see stock is a Postgres column, not a number in memory. The Docker composed the email so they can see the service runs 3 replicas behind the load balancer. And the concurrency test itself orders concurrent.test.ts so they can see the assertion that actually matters. Fire 10 requests at 5 units, exactly 5 succeed. Last round, the winner went and read these on its own. This round, they are preloaded. If reading was the whole difference, giving them the reading should make them win. That's the hypothesis I'm actually testing. Is it the context or is it what the agent does with it? Start with the autocomplete assistant and the result is almost sad. I open all 3 files in the editor, cursor sitting right inside reserveStock, the schema and the compose file 1 tab away. And it did the exact same thing it did last time. It suggested stock equals math.maxVeroStock minus QWERTY. It clamped the number again. The context was inches away and it didn't matter because an autocomplete model doesn't read a project. It reads the few hundred tokens around your cursor and predicts the next line. It has no step where it opens Docker composed UML and thinks about replicas. It can't act on a file it never looks at. Handing it context assumes something that isn't true, that it was ever going to consume context. It's a very good line finisher being asked to make an architecture decision and no amount of open tabs changes what it fundamentally does. Context wasted on an agent that has no mechanism to read it. Cursor is where it gets interesting because cursor can read files. Last time it just read the wrong ones. So I gave it the compose file explicitly and the difference was immediate. It opened Docker composed UML, saw replicas 3, and its whole diagnosis shifted in one sentence. An in-process mutex won't hold across 3 instances. That's the exact realization it never reached on its own last round. With the topology in front of it, it dropped the async mutex approach entirely and reached for something shared across processes. It landed on a Postgres advisory lock, pg.advisory exact lock around the read check write, which does work across replicas because the lock lives in the database every instance shares. Ran the concurrency test, green 200 times. It fixed it. Not the same fix as the winner, heavier than it needed to be, but correct across the cluster. Context turned cursor from a loser into a winner. For the agent that could read, reading was the whole gap. So look at what just happened, because it's the actual lesson. Same context, 2 completely different outcomes. Cursor went from wrong to right. The autocomplete agent didn't move at all. The variable wasn't intelligence and it wasn't the prompt. It was whether the agent has a step where it consumes context and lets it change the plan. Cursor does, it can open a file, read it, and revise its approach. Autocomplete doesn't. It predicts the next token and ships. Context is necessary. Cursor proves that it only won once it could see the replicas. But context isn't sufficient. The autocomplete agent proves that it drowned in context it had no way to use. The winner from last round wasn't winning because it's smart. It was winning because reading before writing is built into how it works. So the moment good context exists, it's already going to use it. Here's where it lands. Giving an agent the right files is the highest leverage thing you can do, but only for an agent built to read them. Cursor was one composed file away from correct the whole time. The model was never the problem. The missing context was. But you cannot upgrade an autocomplete assistant into an architect by opening more tabs because it has no reading step to feed. So the practical rule for you picking a tool: don't ask which model is smartest. Ask whether the agent actually reads your project before it edits it, the schema, the config, the test, because that's the step that turns your context into a correct fix. A reading agent with your files beats a smarter agent flying blind every time. There's one thread I left hanging. Cursor won this round with a Postgres advisory lock, correct, but it wraps the whole recheck right in a lock and serializes every order through it. Claude Code's atomic update, where stock at a greater than or kick never locks at all. It lets the database do the check in one shot. Both are correct. Only one stays fast when 1,000 people check out at once. So next I'm going to load test them side by side. Same correctness, wildly different throughput, and find out how much that heavier than it needed to be actually costs under real traffic. Correct is the floor. Fast is the fight. See you there.